Ladies and gentlemen, boys and girls, thank you all for coming. It's 1600 here in the UK. It is 1800 in Tel Aviv, and it's 8 a.m. on the West Coast. So good afternoon, good evening, and good morning. My name's Martin, and over the next 30 minutes or so, I shall walk you through data wrangling with topic views in Diffusion. I shall introduce the concepts and then show them working in a server or two servers. This webinar is part of a series of webinars, each tackling a fundamental feature that a developer will likely encounter in the development of a solution. I invite you to put your questions to me via the Q&A feature, and we shall answer them as we go through the presentation, or you can click the raise your hand button if you prefer to voice your questions instead. So let's get the ball rolling. What is this video all about? We're going to cover diffusion topic views to manipulate or wrangle your data in the diffusion server. Topic views give you the tools to change the shape of your event data if you need to break up, build up, expand, delay, or throttle your data. If you need any of those things, then topic views are likely your answer. So why is this useful? Or what problem does this solve, as I like to ask? Well, I can think of a few, and there are probably more. So part of the role of a solution architect is often delivering the data, which is often your most valuable asset, to where it needs to be. If the consumer needs the data in a different shape or at a different frequency, this adds an additional step and therefore additional costs and also additional risk. You face questions like, where should we manipulate the data, on the producer or on the consumer? And thankfully, topic views run between the producer and the consumer on the server, and they run transparently as you update your data. They're terse, intelligible, and declarative. Secondly, as we can see, in large organizations or when receiving data from third parties, you're not always perfectly in control of the shape of the data that's delivered. If the data structure doesn't meet requirements, you could change all of your consumers to adapt. But using a topic view or two, instead, you can adapt the incoming data on the server to fit requirements. We're going to cover at least the following subjects. So, cutting data up. We're going to be building data up, renaming, delaying, throttling data, even getting data from around the planet. It's all going to happen on the Diffusion server and rarely with more than a single line of code. So how is this going to work? Well, mostly it's going to be hands-on. There will be a few slides to introduce concepts to set the scene, but we're going to see me work with real foreign exchange data, arriving in a variety of forms, covering a number of real-world problems. And I shall demonstrate how topic views are used to address the issues in the data. Feel free to try out the same features in a free Diffusion cloud service, which you can get yourself from diffusion.cloud. First, let's recap a little. As the name suggests, topic views relate to topics. And this is how I'm going to draw a topic in this video. This topic is called A. It has the value 1. My prior webinar covering the fundamentals of PubSub explored topics in more depth. But for now, think of a diffusion topic as being a variable in the cloud with a path, a type, a value, and optional properties. Subscribers to that topic are delivered a topic's value, and they're delivered updates whenever a topic's value is changed. A topic view is a dynamic way to map one part of a topic tree to another. Here, we're mapping topic A to topic B. The value of A appears both inside A and B. Topic views transform topic data into new topics. Importantly, the original topic is not changed. Instead, the view is calculated and the results are presented in new topics. The view is calculated whenever the source changes, and we call the input topic the source topic, and the output topics the reference topics, as they refer back to the source topic. Topics A and B are the reference topics here. In this example, you can see that we are expanding the source topic, which holds a JSON object. And we'll see how to do this and lots of other features in more detail later on. Topic views can even be used to map topics between separate servers in different clusters in different geographies. There's a lot you can do with this. Let's start with the basics. We'll work our way up to the fun stuff, and the concepts that it's built upon will become clear. The simplest topic view maps a single source topic to a new reference topic. That terminology runs throughout. Topic A is the source topic, and topic B is the reference topic because it refers back to the source. When topic A changes, so does topic B. Your audience can subscribe to topic B and will receive value updates the moment that A changes. You cannot update or remove topic B directly. It is a reflection of its source topic. If topic A is removed, then so is B. If A is recreated, then so is B. A topic view is independent of the topics that it acts upon. Let's see this in real life. Okay. So I have got a diffusion server running locally, and what I'm going to do is I'm going to create a topic and then map it. So first of all, I'm going to create my topic /A. It's going to be a JSON topic. There we are. Let's give it a value. Hello world. And now I am going to give in my other browser, going to add a topic view. And the spec for that is map topic A to topic B. Let's just give myself a bit of space. There we go. And like that, B now exists and it holds the same value as topic A. In fact, outwardly, they're completely identical. The only difference that the console shows us, let's just get rid of those messages. The only difference that the console shows us is that it lists the topic view that creates this. Let's change the value of topic A, and we'll see the effect ripple through the system. I'm going to subscribe to both topics here. There we go. And let's change topic A. We can't change topic B because it's a reference topic. Bonjour à tous. And like that, voila, both topics have changed. Let's now delete topic A, just to prove to ourselves that that'll work. Delete A, excuse me, delete A. And both A and B have vanished. But because the topic view still remains, there it is there, we're going to recreate topic A. In fact, they have both come back into existence. There we go. Then they're both empty. And let's set the value there. Buongiorno tutti. There we go. So in that demonstration, we briefly touched on creating a topic view, and the topic specification took the shape of map source to reference. Now, it would be tedious to map a branch of topics with lots of topic views. So we can use the path directive to do this. This topic view specification will map source and all of its descendants to similarly named topics underneath reference. Two things to notice about this. The source topic clause is now using a topic selector. In fact, it always was, but the extra syntax now really gives it away. And that can be read as the topic called source and everything underneath it at any depth. On the right, the path mapping clause uses the path directive, which evaluates the parts 1 and onward of the source topic path, where 0 is the first part. Let's see what that means with some examples. See how path 1 selects part 1 and onwards from the source topic and neatly gives us, in this case, exactly what we need. In the rightmost column, path takes a second and optional argument, limiting the number of parts to match. Let's try this out. I'm going to take a moment to publish some real-life foreign exchange data. I've got about 4.5 hours of it, so it should probably cover us for today. There we go, it's going. All right, let's have a look at the results. It should be there. Excellent. So what we have here are foreign exchange prices, serialized as JSON, fairly standard stuff for foreign exchange. We have the timestamp, that's timestamp expressed in milliseconds since the epoch. We have the bid price, we have the offer price. They're expressed in two parts for reasons associated with the industry. And we've got the high, the low, the opening of them. And these values will, they're live. Let's have a look at that. If I subscribe to all the content, you can see the data changing in front of us. There we go. What we're going to do is we're going to create a map, a topic view, so that the FX tree is reflected elsewhere. So let's start out by creating a topic view. We're going to call map FX to my FX. And it's FX// to. And here comes the magic, the path. Just give my browser a bit more space. Oh. Here's one I created earlier. There we go. That's created a new branch, which completely reflects all of the topics from the source branch called FX. And these will in every way behave exactly like their source topics, except as we pointed out before in the properties, the topic view property refers back to the topic view that created it. Now, on its own, so we've mapped a whole branch, but if we need to be selective, let's say, for example, you only want currency pairs for the US. Let's do that now. Let's be brave. So I'm going to open my existing topic view. And use the selectivity. USD. So this is an embedded regular expression, but you knew this already. And that will map everything at one level where USD appears in part 1. Yep. And click save. Reflect. Ah. Let's get that right. There we go. And here is a branch of the topic tree filled with reference topics, and only the reference topics that in this case contain USD. And indeed, the path of the topic is called just USFX. So this is a great tool for composing constrained topic branches, say, for example, for service tiers or limiting data visibility to third parties. It's also useful if a third-party data provider's topic structure doesn't meet your needs, because you can use a topic view to map for the data from where they've put it, and you can put it where you need it. So far, we've been mapping topic to topic. Every topic matched by the source topic clause gets a single matching reference topic. When the source topic contains a JSON array or JSON object, we can expand that into many reference topics. And we do this with the expand directive. In this example, we're mapping an object. So intuitively, the property name becomes part of the reference topic path, and the property value becomes the topic value. When expanding JSON arrays, the array index becomes part of the topic path instead. The example object here has two properties, but more often we'll work on much larger objects. We'll see this in an example. Okay, 7 demos today. Let's put some new shaped data into the system. Okay. Now we have two new topics in here, FX array and FX record. As the names suggest, FX array is an array, a JSON array holding the previously seen FX data as an array. And FX record, as you might guess, is, well, it's a JSON object, but hey, we can see it all laid out there. And we're going to break these objects out into more useful, more composable, more referenceable pieces of data. So let's create ourselves a topic view. We're going to call this expand FX record. And the syntax is map FX record to FX record no, that's right. Expand. Okay. We've got the disclosure symbol next to the FX record there. So there we go. So that topic view, expand FX record, has decomposed, has expanded FX record into its component parts. That is an interesting thing to talk about here about topics. So they're often easily confused with files because they use the / file separator. Files, however, cannot contain other files. Whereas a topic can contain both content and have descendant topics as well. So in this case, we have this content, this JSON object, large JSON object, which has been decomposed into smaller pieces. There's still the reflection of the source topic whence they came. And finally, if you need to be explicit about the from where within the source object, the source data you want to retrieve your content from, you can do so with optional arguments to the expand directive. Now, let's cover which problem does this solve. So say your backend uploads its data every few seconds as a JSON array or object. Having your audience subscribe to all of that would be wasteful. It would consume bandwidth and processing time and radio or Wi-Fi time. If you want to give your audience fine-grained access, and indeed fine-grained access control, you break them into discrete topics, and then you have control over what they subscribe to, or indeed what they have permission to access to. Okay, the prior feature, the expand directive, explodes a source topic into many reference topics. This directive, the value directive, can extract a single piece of content from within a JSON topic. So given this source topic, a topic view can extract the bid property into its own topic. There's the spec, there's the result. And likewise with the offer property. So what problem does this solve? Actually, quite a few. Extracting parts of a larger JSON object makes those parts selectable by your audience. And this is great for mobile and web devices where memory, bandwidth, and battery power are at a premium. You can combine this with the permission system so that the source topic is not, which may not be readable, but there are reference topics which are readable, which gives you something close to property level access control. Combined this with topic selectors, and in fact, you can have quite a large effect on the topic tree, as we'll see next. Let's apply this to the results of the last demonstration, in fact. Okay. So here we are. Here are the bid and the offer properties. And we're going to break these out into their own their own reference topics underneath their parent topic. So they are intuitively placed where you would expect them to be. Going to add a new topic view. I'm going to call it breakout bid. It's path 0. Path 0 on its own simply replicates the source topic path that matched it. So that far, that simply replicates the source topic, which it maps into a child topic. Now we're going to use the magic as value. There we go. That's the syntax, right? And the topic view assistant has matched up with that. So let's hit at that. There we go. You can see already the bid fields, bid topics have appeared underneath their parents. And let's do the same for the offer. Here's one I made earlier. It takes much the same shape. Oh, there we go. And there we go. There's the offer topic. So those are broken out properties from their parent topic in this case, which contains all this JSON. And then we just have the smaller pieces. So why is this useful? What problem does this solve? Well, the value directive can extract exactly one thing, but notice here how we're using the split path topic selector. Here we are, the question mark fx record / and then dot star. So we're using regular expressions inside there. In the topic view spec, so we can act once on many topics. So we can actually have quite a large effect, even though we're doing one thing, pulling one thing out of one other thing. Notice also that you can daisy chain topic views. That's probably not the correct view. Probably compose topic views is probably more correct diction. But you can use the output of one topic view as the input to the next topic view. Okay, moving on. If you need to name your reference topic using data from within the source topic, you can do that with the scalar directive. What you can achieve with this is building reference topics containing data from within a source topic. Means you can query, you can select from your source topics according to their content. This is the only way you can do that using a topic selector. So let's say, given a topic looking like this, doesn't have a useful name. It's not useful enough that we can select it. So let's solve that with a topic view, map source to scalar / name. The argument to scalar is an XPath. Excuse me, it's a JSON path. And we're pulling the name property out of the JSON object and the reference topic is named with that. And should the value of that property change, so will the name of the reference topic, because it's a reflection of its source topic. Now, see how the reference topic has taken its name from a property within the source topic. Let's see this put to work for real. But before we do, what problem does this solve? This is ideal for anonymous topics. There's topics carrying a name that's not useful for your audience, and they're trying to select it. Naming things can be hard, so don't be surprised if a third-party data provides data that has a GUID on it or a number for a name. The problem is data that cannot be found has no value. So we're going to use the scalar directive to give it a name that you can find it with, and you can reclaim its value. Right, let's get some data in here. So here we are. FX array, this topic, which we touched on briefly earlier, this is an array of FX data. And we're going to break this out so we can then work on that. So firstly, as before, we're going to give ourselves a new topic array, topic view. I'm going to call this expand FX array. I'm just going to hurry through this because we've seen the expand directive before. We know what it does. And there are the results, but the topics are named with numbers, which is not helpful because we want to select them according to their currency pairs. We want to know about GBP to JPY. We want to know about sterling to yen. We don't want to know about FX array 0. So we're going to create another topic view. Call this one FX array children. And that's going to map from FX array / dot star beg your pardon, path 0, replicating the source topic path / and here's the magic bit, scalar / name. That pulls the name property from the root of the source object. Looks good. Oh, click the wrong button. That's the right button. There we go. So underneath each of these, we now have the same data, but with a much more useful name. So notice how we've used the path directive. When the argument is 0 like this, it evaluates the entirety of the source path that matched it. So let's summarize this example. We've daisy chained 2 topic views to unpack and then rename the objects. And we have renamed them to give them useful names, as consumers will want to select currency pairs by name, not an anonymous number. Okay, so thus far, we focused on breaking topics into smaller pieces. We can use the topic inserts feature to build topics with enriched content. So introduced in Diffusion 6.6 Preview 1, a topic view that uses the topic insert feature produces a reference topic that updates in sync with its source. And inserts data from a second topic at the same time. So let's imagine this source topic and this piece of analysis text. We're going to use a topic view with this spec. Notice the new insert clause, which, as the name suggests, inserts the analysis into a new property in the reference. And you can see the result here. Why use this in the real world? Augmenting your data before delivering it to your audience enriches the entire audience's experience. The alternative is for the audience to place a second subscription, which is easy, but then updating the app, which is not so easy. Let's try this out for real. Okay, I'm just going to draw your attention here to the analysis branch, which we haven't looked at before, containing text about what the trading analysts believe is useful information for people working in this currency pair throughout the day, throughout this trading day. It updates, but not as frequently as the prices do. So let's build ourselves a topic view to merge the two together, to insert the analysis into an enriched topic. So we're going to create a topic view. This is insert FX analysis. FX. To FX with and now the magic. Insert analysis slash path 1 at okay, out there. Oh, I goofed. Let's get that right. We have a new topic branch, FX with analysis. Let's have a look at the content. Let's subscribe to all of this stuff. So down here, FX with analysis, we have now real data, which is really changing and includes a new analysis field, which has been inserted from another topic. We can also throttle topic views. This imposes some limit to the number of updates that a reference topic will receive, independent of the frequency of updates to the source. And we can do this with the throttle keyword. We can see that here, working on imaginary topics, source and reference. So the higher number of updates delivered to the source is constrained to a lower number of updates to the reference topic. Now, there are a few use cases for this. Throttling is a great way of devaluing premium data so it can be shared with non-paying users to incentivize them. Delaying topic views, which we're going to see as well, is another way of producing devalued data, but throttling can be more bandwidth efficient as far fewer updates are delivered to the consumer. You can also combine throttling and delaying for the best of both. Throttling can also be useful in taming very high frequency data feeds before delivering them to a consumer that would otherwise be overwhelmed. In fact, recently there was a use case where a data feed of 15,000 topic updates per second was being delivered to a web browser, and the web browser's networking technology was fast enough to receive them, but the GUI rendering technology was not. So a pragmatic fix went in. We put a topic view in there, throttling the data, and everybody was happy. So let's have a look at this. So delayed topic views use the delay keyword, which we can see here. It pretty much does what it says on the tin. So given these two topics, a source and a reference topic value updates that are delivered to the source topic are delivered to the reference topic after some delay. Let's put both of these to work in the next hands-on. Okay, we're going to create a topic view of our premium FX data feed with embedded analysis, but we're going to throttle it and we're going to delay it. So, as you would expect, we're going to create a new topic view. And I'm going to call it Budget FX and Analysis. And I'm going to start out with this as the topic view specification that maps FX analysis and everything underneath it to budget FX and analysis path 1. There's no magic in there. That's simply going to replicate one topic to another topic. Now we're going to turn on the throttling and the delaying. And I'm going to use the wizard for this. So first of all, I'm going to add a delay. And you can see the GUI, the topic spec updating with the GUI. That we are going to change the delay. Let's say a delay of 10, let's say 30 seconds. And we're also going to put in a throttle. And the throttle is going to be one update every 10 seconds. And there we go, budget FX with analysis. So with a single line of code, our topic view specification, we have a throttled and delayed topic view feed of our premium data. Let's have a look at them. Subscribe, have a look at the subscriptions. Here we go, down at the bottom. So as before, but it's not updating as frequently, which is important if you want to save data, if you want to save bandwidth and therefore save costs. Okay. Moving on. So topic views map one part of a topic tree to another. Introduced in Diffusion 6.5, remote topic views, using remote topic views, we can map topics across geographies. We use the new from clause to make this work. For example, map source from server to reference. But what problem does this solve? So as you'd expect, you can share US data with the EU, but vice versa, you can share EU data with the US, and the shared data can be presented unambiguously in the destination topic tree. Remote topic views also have a place inside the data center for addressing very large audiences where a primary tier of diffusion servers are feed their data to a secondary, much larger tier of secondary diffusion servers, which in turn address a fraction of the audience, the sort of technology that is currently used by fan out. And finally, you can combine remote topic views with all of the other topic view features. So you can kill 2, 3, 4 birds with one stone. Let's do this for real next. I'm going to introduce a new server, but first of all, I'm going to give it some data. Okay. Its name is Ivor. Ivor, the diffusion engine. There we go. Let's log into the console. Ivor's on my network, as you would expect. But it could be anywhere on the internet. There we go. And there we go. There's familiar looking data, but on a totally new machine. And what we want to do now is get that data from afar and present it on my local server in a place that is convenient to me. So first thing we're going to do, just pull this over here. There's Ivor. I'm going to go into the new network tab, which we haven't seen before. And the network tab, in here, we define the location of the remote servers along with the credentials that we're going to talk to. So I'm going to create a server called my other server. tells us immediately that it's connected and it's happy. So we can now use it in a topic view. Let's create a topic view called fx from other server. This map fx / from my other server to a topic path called other server. It's a bit abstract. Path 0. Click add. And we look at our source topic tree. Here we go. There is a new branch called other server, and it contains the other server's data. And we can subscribe to this. In fact, let's do that. Other server. And there is the other server's data, and it is changing in front of our eyes. There we go. So if you're familiar with fan out, this bears some familiarity, except that topic views can be created in both directions quite happily, and of course can be added and removed at runtime, as we've seen, which fan out cannot be. Of course, you can also combine remote topic views with other topic view features as well. So we don't have to merely consume what we're given, we can consume it and we can wrangle it as according to our requirements. So what next? Well, if you're already working with JSON data in topics, then try these techniques out. Chances are you're going to find something that will make your life easier or reduce the amount of data you have to put into your server at the very least. If you're writing code to get data into or out of Diffusion, remember the best code is code you never have to write. All of these features can be used together, as I've mentioned before. In fact, we've already seen combinations of throttling, delaying, and topic selectors used to achieve pretty sophisticated results. So remember also how topic views can be chained together to achieve the result that you want. And finally, watch this space. Topic view features are coming thick and fast, which is excellent news as more and more developers are using JSON topics, and the two technologies work so well together. So before I wrap up, I'm just going to take for questions. We've got a few questions that we're going to address. So got a question from Navina. What's going to happen if the scalar field name is not available in the value of the source topic? Excellent question. So that's down to the scalar directive. If a topic view cannot execute successfully, then the resulting reference topics are not created. So if you try to use a JSON path which cannot be satisfied, then the resulting topic is not existed. There might be the option to use a default value. I'm not intimately familiar with it. I'd have to look into that. The answers are going to be in the manual, but it's not at my fingertips right now. Okay. We got another question from Joshua Cassidy. Crikey, they're coming in thick and fast. Excellent. What happens if a reference topic clashes with a locally created topic? Good question. So, I think that's going to be down to the order of evaluation. I believe if you evaluate a topic view, or a topic view is evaluated, and a topic exists in place there already, it will not overwrite it. And that's not an error. If, however, a reference topic exists and then you try to create a real topic or a non-reference topic through a topic view, I don't know what's going to happen there. That's a really good point, a really good question. Joshua, I will look into that. I'm going to take that as an action and see if we can get you an answer. Oh, there we go. Are topic views visible or accessible across multiple servers in the cluster? Right. So good question. If you are using Diffusion, actually, if you're using Diffusion Cloud, it happens transparently because Diffusion Cloud is actually running in a cluster. But if you're using Diffusion on your own machines, especially for high availability scenarios, it's a really, really good idea to run it in a cluster of 3 or maybe up to 5 boxes. And Diffusion will create create a single federated topic space. Actually, federated is the wrong word. It'll create the illusion of a single topic space. And that goes for topics and also topic views. So if you are talking to one box in the cluster and you create a topic A and a topic view, which creates topic B from topic A, then the effect of that will be visible throughout the entire cluster. Without having to do any extra work. You do not have to know about or talk to the other boxes in the cluster to establish the same topic view. It is topic aware, as we like to say. Okay, and we've got a question from Mr. Bakshi. We can't change topic B because it's a reference topic. Is that a best practice, or is it not allowed or recommended? Okay, right. Yeah, so they are reflections. So reference topics are reflections of their originals. So it's not simply that it's best practice, it's simply that it's not possible. So you cannot interact, you cannot change or remove a reference topic in the same way that you cannot reach into a mirror and change the real world by trying to interact with the mirror. It is beyond your ken. It is a reference topic as a reflection of its source topic. So yeah, they're in every other way, they look exactly like a regular topic, but their existence and their value depends on the source topic that the topic view is acting on. Okay, another question. Burak asks, is there a limit on the number of topics and mappings, and what is the impact on their number or performance? Okay, good question. So Diffusion and Diffusion Cloud, they were both designed, engineered, tested to handle truly enormous numbers of topics. 5 or 6 million topics is not unusual on a game day. So over a weekend, it's not unusual to see a very large number of topics created. And similarly for topic views. But as ever, the answer to a particular question on trying to satisfy yourself as to whether it is running, whether your solution will handle the capacity that you want it to, is to try it out with that capacity. There's an old truism in the business of, if it isn't tested, it's broken. If you want to know where the red lines on a particular solution lie, you've got to drive it until it breaks, which sounds a bit melodramatic, but the truth of it is the platform is built to handle a very large number of topics and a very large number of topic views. However, being smart about it, you want your topic views to be manageable. So you can use a lot of the complexity, a lot of the sophistication in the features of topic views to build a set of reference topics which is reasonable with a limited amount of code. There we go. And another question, do topic properties like persistence, conflation of source topics also apply to reference topics as well? Right. So yes, in every way, the topic, a reference topic refers back to its source topic and then includes topic properties, except when you choose to change the topic properties. There is a feature that we have not alluded to today, where a reference topic can have a different set of topic properties. And that includes things such as, for example, conflation and compression, and also various other properties of topics. So you get to change some of the finer details when you are mapping topics from A to B. Okay. No further questions. Good. Okay, that's great. So thank you all so much for coming today. We did, I think I counted them, 7 demos, and they didn't go shockingly wrong, which is good. So thank you all very much for tuning in. That's a wrap for today. Check back next month, and we're going to cover Diffusion's request response messaging feature. Until then, happy coding. Thank you very much.